So on inverses, let's see, we have reflection over the line y equals x. That's my inverses. They reflect over the line y equals x. So if they reflect over the line y equals x, then we also switch out the x's and the y's in the ordered pairs, because we reflect over y equals x. The other thing about inverse functions is they must pass the horizontal line test. So if it passes the horizontal line test, then it does have a reflection. That function does. So for example, a parabola does not pass my horizontal line test. But if I take my parabola and only take half of the parabola, it then passes, which means then I can reflect it over the line y equals x, and it'll look like this, and that'll be a function. Its inverse will also be a function. Sure, I could take an inverse of this, and it would look like this, but it doesn't turn out to be a function then, because then it fails the vertical line test. So I want to be able to take this function and get an inverse function where the inverse is also a function. So I have to restrict the parabola to half of it and then reflect it over, right? It's reflected over the line. So that's some background on inverses. That's just inverses. I'm not even talking trig yet. So now let's do the inverse of the first trig function, which is sine. Y equals sine of x. So I'm going to do a rough sketch of sine. So let's see. And that's pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2. I need a 1 and a negative 1 for its amplitude. And for sine, my 5 key points look like this. And it continues forever. So does this pass or fail the horizontal line test? It fails. Because sine actually goes forever and ever. Sine looks like this forever. So obviously it does fail. But what I could do is, like the parabola, I could restrict it. I could restrict it to a piece of it. So what I'm going to do is, then I want it the closest to 0, 0. So if I want it the closest to 0, 0, what should I restrict the x's to? To which part of it? I'll wait for an answer. Yes? From negative pi over 2 to pi over 2, because it goes to the lowest point, a relative min, to the highest point, a relative max. So we're going to restrict it right here. So I'm going to go ahead and sketch that out again. Pi over 2 is approximately what decimal? 1.57. So if this is 1.57, then this could be 1. 1 has to be less than that, correct? And I put that on my graph because I'm going to put my restricted sign and then the inverse of my restricted sign. So I need 1s and I need pi's over 2, and I have to know the location of 1. It's not halfway in between. Halfway in between is like 0.75. So let's see. I will do one color sine and another color for the inverse. So for sine, again, sine goes from negative pi over 2 down to 1, 0, 0. And it goes to pi over 2 up to 1. There's my restricted sign. The domain I'm going to use is from negative pi over 2 to pi over 2. And my range is from -1 to 1. So now I'm going to do my inverse function. What else could we say about inverses on domain and range? What happens to those? They get switched, don't they? So my new domain better be from -1 to 1, and my range better be from -π/2 to π/2. Actually, I should have done that one there in orange, because I'm going to sketch that out in orange. So all I do is I switch out those x's and y's. So this is -π/2, -1. Now it's -1, -π/2. 0, 0 maintains itself. This is π/2, 1, so now it's 1 π/2. And again, let's see, maybe I'll do it in pencil. The line y equals x. So we can take the inverse. I just have to restrict it. It's only going to go from -π/2 to π/2. And you're not responsible for graphing this. We're just going to do math with this, but you do need to understand how the graph looks. I'm going to do cosine next, and then we'll do some math with sine and cosine, their inverses. I'll wait on a moment to make sure you've written down everything you'd like to. All right, let's do cosine. Y equals cosine of x. So I'm just going to graph him first, and then figure out where I might need to restrict this one. So let's see. Let's go back to -π/2, π/2, pi, 3π/2, and 2π, and I need to go up to 1 and -1. So let's see. For cosine, we start up high. Here, 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 and here. Ooh. Ooh. Very sad. And then I'm going to go back here. So Victor, where do you think this one is at this time? Almost. The relative max would be at 0. Where's the relative min located at? Pi. From the highest and the lowest. I got the biggest piece of cosine that I could find, from a relative max to a relative min. So now I'm going to sketch that out separately. Well, actually, I didn't need too much over here. I need it more over here, but who knows. Let's see. What do I need? I need a π/2 and a pi. And so this must be π/2. And what do I need to go from? I'm going from 0 to pi, so I need 0 to pi. Oh, actually, I need it this way. Pi. So I need 0 to pi, 0 to pi, 1 to -1, 1 to -1 this way. So I need a 1 here. That's my -π/2, but I need a -1. I don't know. I don't think I need anything down here. Let's take a look. Let's see. Let me graph. Well, I guess I do need a 1. So I guess I'll put my -1, my -π/2. So I'm going to graph my cosine first. Y equals cosine x, just what I did above with the restricted piece. Oh, I guess I need a 1 still. So from 0 goes to 1, π/2 it goes to 0, at pi it goes to -1. So there is the biggest piece of cosine I can find. Take the inverse. That was 0, 1. Now it goes to 1, 0. This is pi over 2, 0. Now I'm going to go to 0, pi over 2. This point here is pi negative 1. Now it goes to negative 1 pi. To help know how it bumps or how it flows is I just go ahead and I sketch this in. My line y equals x, and I know I can see it better how I have to draw this. I'm going to go up here so that this piece is reflected over, and that is y equals the inverse. So let's see. The domain of this one, of this restricted, was from 0 to pi, and then from negative 1 to 1 was the range. So now the range for the orange one is from negative 1 to 1. Oh yeah, that's true. And my domain should be from 0 to pi. 0 to pi. Oh, that is correct. It does match up. So sine and cosine, if I restrict it like the parabola, I will have an inverse function. And I only switch out the x's and y's on that piece that has been restricted. So the blue-green comes from cosine. I restricted it, and I just took those 3 key points, and I just reversed the x and the y. Then to sketch out how it flows, I just drew this line to help me be able to see if it gets reflected this way. Otherwise, I could plot a whole bunch of points to figure it out. So let's see. My summation is for the inverse of sine, I have to restrict my sine from negative pi over 2 to pi over 2. In order to do cosine, my original cosine had to go from 0 to pi. That was my restriction. That's where I had to land. Here we go. I think I'm going to leave that right here. Now, I have my own silly little things that I do to remember things. So for sine, every time I see sine and I have to do math with it to remember its inverse, I draw this. For cosine, I draw this. I'm drawing part of a unit circle. It goes from positive pi over 2 to negative pi over 2, and from 0 to pi, right? From 0 to pi, but from pi over 2 to negative pi over 2. That's where my answers have to lie. That is my restricted domain. So you'll see what I mean. I'm going to start using it. It's going to do some example problems. The inverse sine of square root of 3 over 2. So since I'm doing inverse of sine, I'm restricted. I must only choose an answer for my angle to be in between pi over 2 and negative pi over 2. Sometimes that's hard for me to see. Sometimes when I'll come over here, I'll come to the side. I'm going to switch out this x and y. It's like, what is my theta for a positive square root of 3 over 2? So first off, so I'm going to draw my little sign, my little cheat thing. I also know this is where sine is positive here and sine is negative down here. Well, this one's positive. It's going to be in quadrant 1. What gives me square root of 3 over 2? What kind of angle measurement? Pi over 3. So that's the answer. It's the inverse. They're switched. I go back to here, but I know whatever answer I put here is within this restricted domain. I can only have answers here. I cannot have an answer like 2 pi over 3. That's not in this restricted domain. It has to be from pi over 2 to negative pi over 2. So let's try another one. So again, I'm going to still use my cute little picture here. Maybe I will write it this way. So I'm going to be down here in this quadrant 4, correct? Because this is a negative answer. And what angle is that? You may not say 5 pi over 4. It's negative pi over 4. Isn't it really 7 pi over 4? But I cannot say 7 pi over 4. I have to say something in between here. So isn't that negative pi over 4? Negative pi over 4 is the same thing as 7 pi over 4. Those are those coterminal angles? Oops. Oh, I switched to cosine. I'm going to draw up my picture. I know my answers are between 0 and pi. For cosine, which is on the x-axis, my positive cosine is here, my negative cosine is here. So maybe I'll look at it forward. I want to figure out what theta, what angle measurement gives me a negative 1/2. So I'm going to be in quadrant 2, aren't I? And what will that be? Between 0 and pi. What is it? 3 pi over 4. No, not the 4. 4 has a square root of 2 over 2's. Oh, this is fun. We forgot our unit circle. Yummy. What is it? Thank you so much. That does lie between 0 and pi, 2 pi over 3. Let's try another one. In other words, what theta will give me a positive square root of 2 over 2? So now I'm in quadrant 1. What will that be? Pi over 4. Okay, ask me some questions because I didn't plan on doing any more than those 4 for sine and cosine. I'm now going to go and do tangent. Do you know what I did? I know we would want to say 7 pi over 4, okay, right here, but how can I get there? Either this way, the 7 pi over 4, or this way, negative pi over 4. I must say it like that because I can only say an answer. And so remember, pi over 2 and negative pi over 2 comes from that straight line, from negative pi over 2 to pi over 2. What kind of answers can you give me here? That's all you can give me. 7 pi over 4 is way over here. That's on the outside of my restriction. You may not say it. From the graph, it's between negative pi over 2 and pi over 2. That's what you told me on sine. Between negative pi over 2 and pi over 2 is the only place I can have my answers on my inverse sine, because that's what I have to restrict it to. You may not say pi. You may not say negative 2 pi. Somewhere in between. Okay. Y equals tangent of x. Well, you see it in your head. You can tell it already fails, right? You have a whole bunch of vertical asymptotes, and between a set of vertical asymptotes is 1 period. So I might as well pick the one that goes right in between the origin 0, 0, which is at negative pi over 2 to pi over 2. It's my vertical asymptotes, 0, 0. Cut that in half. That is what? Pi over 4 and negative pi over 4. And I need a 1 and a negative 1. So that goes up here and down here. That passes my vertical line test. The moment I put the next period on either side, it fails. So it's going to be restricted down to 1 period, from negative pi over 2 to pi over 2. So now this cute little picture, we're not even done yet. This cute little picture is going to be the same as sine. Pi over 2 to negative pi over 2. Let's go ahead and come up with its inverse. I'm going to do it right here on this. So let's see, what do I need? On this axis, I need some pi over 4s and pi over 2s. So this is a pi over 2. This is a negative pi over 2, because that's bigger than a 1 and negative 1. And then pi over 4 is in between here, in between here and here. On this axis, I need to have some 1s and negative 1s. So this will be my negative 1, and this will be my 1. Now I'm set up. Let's see. 0, 0 stays. Well, actually, let's move my asymptotes. Negative pi over, okay, so this would be a point. This is negative pi over 2, 0. Now I'm going to go 0, negative pi over 2. My vertical asymptote gets moved here. This vertical asymptote is the point pi over 2, 0. So now it's 0, pi over 2. So it has two horizontal asymptotes. 0, 0 maintains. This point here is pi over 4, 1. So now it is 1 pi over 4. This point here is negative pi over 4, 1. Now, I'm sorry, negative 1. Now it's negative 1, negative pi over 4. Oops. Oops. And that is across this line.
Repeat what you said.
Okay, so what is it that you need? You just switch every ordered pair. These three right here. Those are my original tangent points on my blue-green. So this point was negative pi over 4, negative 1. Now it's negative 1, negative pi over 4. This point here was pi over 4, 1. Now it's 1 pi over 4. And it has clearly been reflected. The asymptotes have been reflected. The graph has been reflected. So let's try some problems. Inverse of tangent of negative 1 equals what theta? Well, let's write it this way. Tangent of theta equals negative 1. So my cute little picture is like this. Oops, positive pi over 2 to negative pi over 2. This is a negative answer, so I'm down here in quadrant 4 somewhere, because that's where it's negative, this is where it's positive. And so where might I get a negative 1 at? Down here. Pi over 4. What kind of pi over 4? That's up here in quadrant 1. Negative pi over 4. That's my theta. Let's try another one. The inverse tangent of the square root of 3. In other words, tangent of theta. Oh, that's going to be up here in quadrant 1 because it's positive. That tangent is a positive ratio. So where am I going to get a square root of 3? So you can jot it down in your paper. Which one is it? 1/2 over square root of 3 over 2 or square root of 3 over 2 over 1/2? Which one is it? Pi over 6? Let's see. Pi over 6 is sine over cosine. Or is it pi over 3? Square root of 3 over 2 over 1/2. Looks like it's pi over 3. Again, we need to do the math over to the side. Don't just leave it in your head. Do the math. As soon as you do the math, you could easily see it. Well, I have to remember for the first two, I have to have an answer here. This one here is going to be in quadrant 1. So I need to do 0.2. I'm in radians. I got to find my inverse sine, so I got to push second. There it is. And so that that angle measurement is 0.201. We'll go 3 places. 0.201. So let's see. Pi over 2 is 1.57, so that's really small. So that means sine of 0.201 equals 0.2. that is really small. Take a pi over 2, that's 1.57. And so I just want point 2 that's really going to be small angle, like maybe a 10-degree angle. Let's try the next one. So 0.4, make it negative. Inverse sine, make sure it's radians, I do. Inverse sine. And that's negative 0.412. In other words, sine of negative 0.412 equals 0.4. I'm sorry, negative 0.4. So again, I'm down here in quadrant 4, and it should be a negative answer. It does. If I put in a negative angle, it better be a negative answer, because sine is negative down here in quadrant 4. And that's probably only about a 20-degree angle. I'm going to try doing cosine. This is positive. I better get positive. So what angle am I going to put in? I'm going to put in 0.3. I want the inverse of cosine. So 1.266. In other words, that means cosine of 1.266. Oh, that's getting closer to pi over 2. Pi over 2 is 1.57 equals 0.3. Uh, 0.1, make it negative. Okay, I did. And take the inverse cosine, and that is 1.671. I rounded it to 3 places. In other words, that means cosine of 1.671 equals negative 0.1. Now wait a minute, I'm in cosine. Cosine looks like this. This is the positive, this is the negative. So this one here, my answer was negative, which means this answer better be in quadrant 2. It is in quadrant 2. That's a quadrant 2 angle. That's past 1.57. That's past pi over 2. So that does make logical sense. Let's see, tangent. 1.5 and stays positive for my inverse tangent, and that's 0.983. In other words, tangent of 0.983 equals 1.5. Again, tangent and sine share the same pattern. So this is positive, that's in quadrant 1, I better have a positive answer. Next one, 3.2, kind of make it negative. That means I'm down here in quadrant 4, I better have a negative answer here for a negative angle measurement. Inverse tangent, and that is negative 1.268. So that means tangent of negative 1.268 angle. That's less than negative pi over 2. It's something less than that. I didn't quite reach it, but I'm down here in quadrant 4. Equals what kind of angle measurement? Negative 3.2. It should be negative. The answer should be negative because it's down here in quadrant 4. Go ahead.
Hello? Oh, this is her. Hi.
Okay, we all okay? We're okay with this?
Sure.
Just a calculator problem. Last for today. Evaluating a composite trig expression. Composite, that's when we took two functions and we put one inside of another. We're going to go evaluate that We just got done evaluating with a calculator. We evaluated using inverse functions. Now we're going to evaluate it when I'm going to take them and make them a composite, such as
What's inside?
inside the parenthesis. Is this an inverse function? No. So just go do sine of pi over 3. What is that? Square root of 3 over 2, right? So I'm going to put that answer inside the parentheses. Right? Didn't we just answer what's in the parenthesis? Now I'm on an inverse function. So whatever I put here has to be an answer between pi over 2 and negative pi over 2. So that's positive, so it's going to be up here in quadrant 1. So what is that answer? We happen to get the same thing back. Sometimes you get that. Right? Let's try the next one. Yes? I have to think of what angle measurement. When I take the sine of it, I get a square root of 3 over 2. So that's where it's really tall. So that must be the pi over 3, the largest angle. Right? Okay. Next one. I do what's in the parentheses first, but what's in the parentheses is my inverse function this time, right? So when I do this, it has to be in here. Well, didn't I just do this? So I happen to know that one. It's what? So I'm going to go ahead and put that in there. What's sine of pi over 3? Oh, happen to give you the same thing back. It doesn't always do that. Sometimes it does and sometimes it doesn't. If you develop the pattern, find out when it does and when it doesn't, great. And if you don't, work it out every time. Okay, I'm going to do what's in the parenthesis first. Is that inverse function inside? No, it is not. So sine of negative pi over 3 is what? Negative square root of 3 over 2, right? So I'm going to write this down. Negative square root of 3 over 2. So I'm still in sine. I'm still using this picture. The output, remember, because that's really the output. I'm used to seeing the angle here. The output's down here in quadrant 4, so I better have a quadrant 4 answer. What's my quadrant 4 answer? Negative pi over 3. Let's do this one. Inside is inverse first, correct? So the inverse of negative square root of 3 over 2. Oh, we just did that, right? So let's go ahead and just copy. Sine of negative pi over 3. Well, I should get a negative answer. So I'm still getting the same thing back. This one here is cosine of 2. Is that an inverse? No. So that's an angle measurement. Where does the angle measurement 2 lie on my unit circle? What quadrant? Where is it at? No. What? It's an angle measurement because it's not an inverse. So that's an angle measurement. That's my theta. My theta is 2. It's in quadrant 2. Because it's in quadrant 1 from 0 to pi over 2, and pi over 2 is 1.57. Isn't that bigger than 1.57? But pi, which is the end of quadrant 2, is 3.14. So isn't 2 between 1.57 and 3.14? So this is a quadrant 2 angle. So I don't know what that answer is. I guess I have to take out my handy-dandy calculator. Negative 0.4, whoops, I forgot to write it the right way. Right? Is that what you got? So I left it in my calculator, this number without losing all the digits. I actually have the whole thing still in there. And so now I'm just supposed to take the inverse cosine of it, right? So I might as well just leave it in there and take the inverse cosine of it. This next one is an inverse. I've got on inverses. 0.4 inverse cosine. So that would be cosine of 1.159. Is that angle measurement 1.159 in quadrant 1 or quadrant 2? 1. It's less than 1.57. I left that number in there. Now I'm going to go ahead and just take the cosine of it. So every one of these resorted back to the original.